In the experimental setup given below, it is observed that on passing the gas produced in the reaction in the solution X, the solution X first turns milky and then colorless. The option that justifies the above stated observation is that X is aqueous calcium hydroxide and A. It turns milky due to carbon dioxide gas liberated in the reaction, and after some time it becomes colorless due to formation of calcium carbonate. B. It turns milky due to formation of calcium carbonate, and on passing excess of carbon dioxide it becomes colorless due to formation of calcium hydrogen carbonate, which is soluble in water. C. It turns milky due to passing of carbon dioxide through it. It turns colorless as on further passing carbon dioxide, sodium hydrogen carbonate is formed, which is soluble in water. D. The carbon dioxide liberated during the reaction turns lime water milky due to formation of calcium hydrogen carbonate, and after some time it turns colorless due to formation of calcium carbonate, which is soluble in water. Here's the explanation. Observation: a clear solution labeled X turns milky when carbon dioxide gas is bubbled through it and then becomes colorless after some time. Option B: the solution contains calcium hydroxide, which reacts with carbon dioxide to form a white precipitate of calcium carbonate, making the solution milky. Upon excess carbon dioxide, the precipitate dissolves, forming calcium bicarbonate, making the solution clear again. This explanation aligns accurately with the observations. Initial milkiness: when CO2 is bubbled through the solution, it reacts with calcium hydroxide, CaOH2, to form calcium carbonate, CaCO3, precipitate. This precipitate is initially dispersed in the solution, causing the milkiness. CaOH2aq plus CO2G CaCO3S plus H2O, Colorlessness: however, calcium carbonate has limited solubility in water. As more CO2 is added, the concentration of dissolved CO2 increases, leading to the formation of the more soluble calcium bicarbonate, CaHCO3, according to Le Chatelier's principle. CaCO3S plus CO2G plus H2O CaHCO3 This shift in equilibrium dissolves the previously formed calcium carbonate precipitate, making the solution clear again. Therefore, option B is the correct explanation, as it accurately describes both the initial milkiness due to calcium carbonate precipitation and the subsequent colorlessness due to its conversion to the more soluble calcium bicarbonate.